Okay, lesson number 61, Algebra 2, Chemical Mixture Problems, Type B. Alright, at this point we have had a container full of something and a container full of something over here, and both of them were dumped into another container over here. Let's make it different colors here. It adds a lot more fun to it. So we've got something in that container, and we have something in that container. We dump that out, we dump that in there, and it gives us a final product there. Okay, so this one, or this section, we're going to start out with a certain amount in a container. So we've got this amount of stuff in this container, and let's say that it warms up and some of our water evaporates out, because if you know anything about like salt water, when the sun causes evaporation, only the fresh water evaporates out, the salt stays in there. So let's say that this is 30% salt. Well, as water starts evaporating out, the concentration of salt gets higher. There becomes more and more salt because there becomes less and less fresh water. So as we take the fresh water out and leave the salt in, the percentage of salt increases. There doesn't become more salt because we didn't add any to it, but the ratio of salt to water increases. So let's say we started with 60 gallons. So let's say that 20 out of that 60 gallons, 20 gallons is salt out of that 60 gallons. That'd be around 33%. Okay? Well, let's say that some of that water evaporates, and let's say the salt all stayed there, and we evaporated, say, 20 gallons of water, which means now we only have 40, which means we have 50% of that solution is now salt. So the salt amount didn't increase, but the amount of water decreased. So that changed the concentration. Alright, so that's kind of what we're going to be looking at in this lesson. So let's go ahead and start with the first one. 61.1. How much water must be evaporated from 100 gallons? Alright, so here's our barrel of 100 gallons. Out of that 100 gallons, 10% is, it says a brine solution. A brine solution has to do with salt. Alright, so how much water must be evaporated from 100 gallons of a 10% brine solution to get a 40% brine solution? So we want 40% brine instead of 10. So we're going to have to lower the amount of water here so that the percentage of the salt to the water increases. So we start with our water that we have. We evaporate water out, H2O, and that gives us our final amount of water. So that's what's happening. So we're going to go water that we have minus the water that we evaporate equals the water in the end. So what did we start with? We started with 100 gallons. We are evaporating some water, and we are going to end up with, I don't know how many gallons, but I do know it's going to be what we started with minus what evaporated, right? That'll be how much we have left. Alright, so let's put at, we have a 10% salt solution, so that means we have a 90% water solution, right? So 0.9. That is our solution that we begin with. We are going to evaporate, and it's going to be 100% water. Nothing's going to change, so I guess if you're going to use 100%, we'd put a 1 there, but we don't need to because it's not going to change anything. And what do we want for an ending? We want a 40% brine solution, but since we were dealing with water here, we're going to have to deal with water here. Okay? We could have written this as a 10% salt solution. Maybe that's what we should do. Minus the amount we evaporated equals a 40% salt solution. Let's just go ahead and do it that way. That might be easier. You can do it either way. It doesn't really matter. But let's stick with salt. But because we are sticking with salt, we have to look at how much salt was evaporated. No salt was evaporated, so the number that goes here on the amount of salt evaporated would be 0. Alright, so that takes us, oops, my 0 didn't follow me. That takes me to 10.1 times 100 minus 0e would be 0, because we had 0 amount of salt evaporate. That equals 0.4 times 100, which is 40. 0.4 times e is 0.4 e. That can go away. Subtract 40 from both sides. So we get negative 30 equals negative 0.40 e. Divide by negative 0.40 by negative 0.40. Those go away. Two negatives give me a positive. And that gives me the amount evaporated is 75. So 75 gallons of fresh water to evaporate in order for me to change my brine solution from a 10% solution to a 20% solution. Alright, so let's try a couple more examples and call it good. So example 61.2, when Frank and Mark finished milking, they found they had 900 pounds of milk. That was 2% butterfat. How much butterfat did they have to add to raise the butterfat content to 8%? Okay, so now what we're doing is we are taking an amount that we started with, in this case 900 pounds. I don't know why they do it in pounds and not gallons, but 900 pounds. And we want to add butterfat, so say the number of pounds of butterfat. The book uses a P of N, number of pounds of butterfat, to get, what does it say? I'm sorry, I'm a little off here. A content of 8%. So this is 2%. We want to add enough butterfat here to give us an 8% of butterfat. So we're going to have to add some to it to raise the percentage of butterfat there. Alright, that being the case, when we add those two, we get 900 plus our amount of butterfat. So this is what we've started, this is what we're adding, and this is what we have once we add those two together. So not really a whole lot. So let's work with the butterfat here. So what did we start out with? 0.02, 2% of butterfat. Okay? And we're going to add 100% of butterfat. 100% in decimal is 1. So it doesn't really even need to be there, but wanted to put it there just so you know what we've got. And we're trying to get an 8% of butterfat. So when we're done, that's going to be an 8% solution, or whatever you want to call it. Then you just multiply. Those two multiplied together give you 18. 0.08 times 900 is going to give you 72. So that times that. And then this times this is going to be 0.08 P of n. And then we solve for P of n. When you solve for P of n, then you're going to get 58.7 pounds of butterfat that you're going to have to add to this 900 in order for that percentage to go from 2% up to 8%. And that's it. Alright, one more. Alright, so again, following this method, first of all, let's see what we've got. Virginia and Campbell had 100 kilograms of glycol solution. So we've got our glycol. And they want to add something. They want to add glycol, but I don't know how much. So that, and that's going to give me my final amount. What I started with, what I added, is going to give me my final amount. So that's what I've got. Okay, so let's write. What do we have? We have 100 to start out with. Okay? We're going to add some more. Oops. What do they use? They use P of n. I don't know why they use P of n. Poured in, maybe. And that is going to equal how much we started with how much we poured in. Okay, so there's our formula. Now we just stick the percentages. We started with a 20%. We are adding a 40% solution. Okay, if we were doing 100%, that would be a 1, but since it's a 40%, we're adding 0.4. And that gives me, and we want to get a 35%. So you just put your percentages in front of what you're adding. Alright, so now we have 20 plus 0.40 P of n equals 35 plus 0.35 P of n. Okay, nothing really crazy. Solve for P of n and you get, you move these things around a little bit and we get 0.05 P of n equals 15. Divide by 0.05 and 15 divided by 0.05 is going to be 300. So we started with 100 kilograms, and in order to get that percentage from a 20% to a 40, or in order to get that 20% up to 35%, we have to add another 300 kilograms of the 40% solution. Now again, if we would have added 100% solution, it wouldn't have taken as much to raise that percent. But since it was only 40, it took more. Okay, so that is lesson number 61. The practice problem as well as number 3 and 4 and 5 are going to be the exact same. So don't freak out about these. Just do it the exact same way that I showed you, and you should be good. If you took notes and did them well, you should be able to refer back to your notes and not have any problem at all with lesson number 61.